Hey everybody. I do a lot of posts on both Facebook and Instagram, and now I'm starting to do some Twitter and some TikTok. I also have some videos on YouTube, and I realize it's a lot of content. It's all over the place. So I kind of want to do a longer format video right now, just to level set everybody that's wondering what this project's all about. So if you followed me or if you've seen the car on social media before, you'll know this is a 2015 Fiat 500e. It's an electric car. It's completely walled off. I have 612s in here. They're Fiat audio, the SP4 V2 Plus, and the doors. I have two 8-inch sundown audio, and then one Rockford Fosgate, plus 1-inch silk dome tweeter, and then the A pillars I have gel audio 3.5s. So you take that, you double it up. Welded roof with reinforced brace. Again, on social media you'll see a lot of videos of the build if you're interested. But what I've been doing for the last few months, I dropped my custom lithium batteries, and I dropped my three 12K 12-volt amplifiers, and I've been moving to a high voltage amp. These are the positives and negatives coming in from the main traction battery that I tied into. Again, lots of info on social media, videos, posts, etc. of how I did that. And they're coming in to these big breakers. I actually have breakers towards the front of the car, and then these over here. And what I'm working on now is really a custom system designed to provide power to a 400 volt amp that's going to go right here with a lot of safety built in. So first off, this 12 volt system will be powered by these lithium cells. Headways 8 amp hour each, so I'll have 16 amp hours of headways. These are good for a constant 5C discharge and 10C max. So I'm looking at about 80 amps constant. I will not need anywhere near that amount of current, but again, I prefer lithium, lighter, and a lot better performance. The way the system will work is I'm going to have the 12 volts from the car coming into the system. When the system detects that there's no current or voltage coming in from the main traction battery because the car is off, it's going to turn on a relay which will connect the 12 volt system of the car through a diode to these batteries. So while the car is off, these batteries will get recharged from the big AGM battery that I have built into the car. As soon as the car turns on and the system senses either a spike in voltage from the 12 volt system coming from the car because the main DC converter is on, or a signal from this high voltage battery, it's going to kill that relay and isolate the system, the 12 volt system, completely from the car. At that point, through one of these big relays here, one of these breakers and these big relays, a DC to DC converter over here will turn on. That converter allows me to take in 400 volts and feed the 12 volt system that I have here. So instead of charging from the main 12 volt system in the car, it'll now have this feeding it. So this one will be fed this way. Once all that is up and running and everything is stable, once a car gets one of the remote lines, I have a switch at the front coming in that says, hey, I really do want bass, turn it on. It does, continuous monitoring at about 100 milliseconds, so 10 times a second it's monitoring everything. Once the system says everything is ready, voltage is being supplied properly through this DC to DC converter, it's going to turn on this relay. This relay is going to run through this thermistor here, and it's going to do two things. It's going to first charge the capacitors in the big amplifier, and also charge these big capacitors. I have two more coming in. This is going to be 3200 microfarads worth of capacitance to level out the big high voltage line coming in. It's going to turn this guy on, which again has resistance. That way we slow down the inrush current not to blow any components. And eventually this relay will turn off after this big guy turns on. So this big guy will allow main current going in from the main amplifier to connect directly to the battery pack in the car with parallel for these capacitors here. So then this guy can turn off because he's done his job. These are all sized appropriately and will limit current to the converter, to the thermistor, etc. So everything is calculated. The main controller of this system will be this Pi board over here that is being fed through a bunch of fuses for power, fuses for the relays going into these bigger relays. And here's a custom sensor board I built. This sensor board will sense the voltage on the relays, both the 400 volt power as well as whether or not the 12 volt is coming in as expected. This way, if I have a fuse pop, the system will know because it's going to trigger this guy, yet it won't see any voltage going through and turning the relays off. So again, a lot of custom code in there to make sure everything is safe. This will again be connected to this battery pack. And the goal is to run at around 40,000 watts RMS from my traction battery to the subwoofers. And again, I have lots of videos on here. You guys can check them out. Here's just a quick sample for those that are not familiar with the project. So we turn on a relay. See these guys turning on, which in turn turn these guys and will allow the high voltage to flow through. Again, all of this will be run by a custom system I developed. And I'm going to be feeding all of the sensor data that you can see I'm capturing every 100 milliseconds. It will be fed into a machine learning framework that will determine all the proper voltages, all the spikes it should see, not just when the different components are being turned on and off, but during driving conditions. So all of this will be connected via Bluetooth to an OBD2 controller I have tied into the car right here. So as I'm playing the system and I'm driving, there's going to be a lot of voltage spikes and amperage spikes up and down. So the system will eventually be able to correlate all of the data from the motor, from the main converter in the car, and all my system here, and determine that everything is still safe. If at any point in time we see anything out of the norm, the ML framework should act as yet another layer of safety that can put the system in a faulted state, immediately turn off the relays, shut everything down. And of course, at that point in time, the system should theoretically become safe. Even though back here we're going to have a lot of capacitance and a lot of voltage stored up in these components, the idea is as long as the system's turned off, no more voltage is coming in from the main battery into these components. So they could be safely discharged, and then the system can be, maintained or what have you. So if you're interested in what you see, from my knowledge, again, I'm the first person in the world doing this to the traction battery of an electric car. I haven't seen this done before. So if you're interested, you want to follow along, you want to learn a little bit more, please feel free to follow along. Loud Fiat on Instagram, Loud Fiat Facebook, Loud Fiat TikTok, Loud Fiat Twitter, and my normal YouTube channel where you're finding this right now, under my personal account. Any questions? Feel free to ask. I'm going to keep providing more info. Once the system is running, I'm going to dive into deeper technical details. I had one amp. It was a Sound Digital 100K. Unfortunately, 400 volts was too high for it. Even though it's rated for 400 volts, I had one blow on me, and the second one almost caught fire. So clearly, it did not like 400 volts. I'm hoping the new amp that I have, which will be a Stetson Force 1 rated at 440 volts, will be able to take 400 volts without an issue. I'll keep everybody updated. Thank you for watching.